So looking at number 3 on quiz 5A. What do we have? It says, suppose that a student who scored 48.5 on her midterm got her grade raised to a 50. Indicate whether changing the midterm score for that student would make each of the following statistics increase, decrease, or stay the same. So we're thinking one student out of the whole class. Were there like 16 kids in that class? I can't remember. 18, 16? 16? Okay. So let's summarize that. So we got 16 students. That's how many pieces of data we have, right? What are we doing with one of those pieces of data? Increasing by 0. So the maximum piece of data, in fact, the max piece of data increases. And they asked us, how's that affect lots of different statistics, right? So we want to think about how does that affect the mean, what's it do with that? Does that affect the median, what's it do with that? Does that affect the range, the IQR, and the standard deviation? So these are all different statistics. They are not the only statistics that exist, but they're probably some of the most common ones we're going to be using this year for like all year. Does that make sense? So how many center statistics are there out of those 5? How many of those measure the center? 2. Mean and median. How many of those measure spread? 3. The worst measure of spread is which one? Range, because it doesn't tell you hardly anything, right? Standard deviation and IQR are much better measures of spread. Which ones you use? Remember, you decide by looking at the shape and also sometimes looking to see if there are outliers. Good. Very nice. Okay, so mean. If we take that biggest piece of data in this situation and make it a little bit bigger, how does it affect the mean?
Increases it.
It's going to increase it by how much?
Not very much.
Just a teeny tiny bit, right? So let's put that. So not only are we going to say increases, let's give an idea of scale. So it's going to increase the mean a teeny bit. That's pretty specific. Without all the data actually having it, we don't know how much. Okay, median. What's it going to do to the median? Nothing. Why? Because they're lined up in order, and the fact that the top one changed in scale doesn't mean anything about where the middle was, right? So this is going to stay the same, or stay constant, or remain constant, however you want to say that. Cool. The range. Is it going to affect the range? What's it going to do to that if so?
Increase the range.
Since it's the fact that it's the very top thing over here, isn't it going to blow the range up a little bit? It's going to make it a little bit wider. So it's going to increase the range. I guess we could say a lot or a little bit. Go back and look at that. Isn't this the same data from the other side? I think it is. So the range was like 48 minus 16. That's 32. So now it's like 32, 33 and a half. So just a little bit. All right, what do you guys think? IQR? The IQR is going to stay the same too, because this is the maximum piece of data, and the IQR is the median of the median here, and the median of the median here, the 75th percent and 25th percent. It's not going to change those at all. So that's going to stay the same too. Is it going to do anything to the standard deviation? Standard deviation is probably the thing that should be, a little harder for you to think about for now, since we haven't done much with it. What do you guys think?
Tiny bit.
You think increase a tiny bit, Kinsey? You guys agree with her? Not sure? Standard deviation measures spread, right? And it takes, remember yesterday when we did that calculation where we took all the lists in our calculator, it takes each piece of data, every single piece, looks at its difference from the average, squares it and does other stuff, but the key is that it looks at every single piece of data and takes it into account. So will it change? Yes. And since it's getting bigger this way, that's going to spread the data out a wee bit more. So, yeah, it's going to increase just a tad. tad. Increase, let's put another word in here. Increase the spread, which that standard deviation is trying to measure a tad bit. Okay, let's look at number 4 on the quiz A. So number 4 has those box plots representing GPAs broken down by class of juniors, seniors, and sophomores in autumn 2003 of an intro stats class that we still don't know where. Darn it. Oh well. So which class had the lowest cumulative GPA, and what's the approximate value of that GPA? What are they asking for? You need to translate. In statistics, all the time, you've got to change the wording of a problem. Put it in your own words. Paraphrase it. If you don't, you're not going to be good at statistics. So that's absolutely essential. What are they asking for here? What's the approximate value of the lowest cumulative GPA? What do they want?
Who has the minimum?
Yes, perfect. That's great, Mary. I love it. Who has the minimum? What's the minimum? Look at all 3 minimums and find the smallest one. So the smallest one belongs to what class? Juniors, and it's like what? You gotta guess. 1.6, 1.7, something like that. Yeah. Okay. B says, which class has the highest median GPA, and what is that GPA? Well, that's pretty simple. I don't think we really need to paraphrase. Where should we be looking on the box and whisker plots?
The divider.
The middle bar, right? So which one has the highest? That's pretty easy. It's the sophomores. You just guess at it. What, 3.3, something like that? You guys, so far I've been looking at your investigative tasks, and a huge amount of people didn't even put like dollars on theirs. Like if you leave units out, that's like the most basic part of context possible. It's a big no-no. So you always got to put units. Here the units are what? GPA. Like that's not very specific, but units are always supposed to be in a problem. You leave that out, the AP people are going to go, your grade just lowered. C. Which class has the largest range? I think that's pretty easy again. We don't have to paraphrase, it's just min minus max, or excuse me, max minus min, right? You can just look at it from the picture. Which one looks like it has the biggest range? Just look at the whiskers. The juniors, right? So then you look at that range and say it's like what? 4-ish minus, what we call that, 1.6. So 4 minus 1.6, 2.4. That was pretty easy. Which class has the most symmetric set of GPAs? And which one's the most skewed?
Seniors have most.
Symmetry.
You guys agree with Kinsey? Seniors most symmetric?
Most definitely do.
Yeah, I think so. That long whisker on the bottom of the juniors kind of pulls it a little bit skewed to the right. Which one's most skewed though?
The sophomores.
I think the sophomores. On which direction is it skewed?
To
To the right. I saw several people pick the skew on their investigative task the wrong way as well. If you have a picture like this and it has upside down box plot, like here's the juniors for that problem, it looks something like this. Or no, I'm doing sophomores, sorry, sophomores. It looks about like this, doesn't it? The middle part looks fairly symmetric, but then this whisker goes way down. If you have a vertical thing like that, whether it's a stem and leaf plot or a box plot, you should be taking that and turning it like this. So look at this and redraw it. Something like that, right? Which direction is the tail? Tail is to the right, that means it's skewed to the right. If you had this on a histogram, because of course if we had this data, can we put it in a histogram? The histogram would look like probably highest like right there, then again right here, then maybe like right here, and then it might be like, and you can see that it's clearly skewed to the right. Histogram would look something like that. Okay? All right, let's look at an ogive. Did you guys have a problem in your assignment? I was thinking we'd look at an example, so you guys can get some practice. That's another kind of plot. So this section's going to have histograms. It's going to have box plots. It's going to have stem and leaf plots. It has one other kind of graph we haven't talked about, which is an ogive. Don't let an ogive scare you. It's basically just another way to do a box plot. So you can pull out the same information on it. Let me see if I can find one in the book. Let's see here. And no, yes, I know it looks like Ogive, but it's not. You pronounce it Ogive. Where is it? Is this in the problems?
Yeah, it was like over last month.
Okay, I'll just make up an example. So ogive plots, your calculator can't do an ogive, but every once in a while they put one on the AP exam, and I think that's good because they're not real hard. And pretty common out there in psychology and stuff. So an ogive usually has like percentages here, cumulative percentages, and it should be out of 100%. So it'll have something like that. And I don't know, we've always got to label our plots, right? So we didn't do that in the investigative task either. So like those are percentages, that's pretty clear. Let's make an ogive for, let me think. What do you want to do? Do you have an idea? Let's say coffees consumed per month. By who? Good question. Starbucks enthusiasts.
By Lawrence.
And I can't spell. Starbucks enthusiasts of Pokemon. So, we want to look at how many coffees that these people are consuming per month. We can, of course, apply that to Colorado Springs or non-Starbucks enthusiasts, whatever that means. But what's typical for these people? So, I don't know. I'm going to draw a random curve. Ogives usually look something like that. You don't have to have a specific shape. So what do you guys think is reasonable for a Starbucks enthusiast? What should we put on here? What do you guys think like the average number of coffees consumed for a true Starbucks enthusiast
Only
is?
Starbucks coffees?
Is it
Yeah, just
Per
Starbucks
day, per
coffees.
what?
So like
I'd say at least
15?
15 or 20?
Oh my
For
god.
what?
Over a
what?
month?
Over a month.
That's per month.
Honestly, if
One
they're
a day.
enthusiasts, they get at least
It's
one
like
a day.
one a day.
They
Like
get like
30.
Really?
One a day, yeah. If you're a
At least one a day. Sometimes it's
At
wrong.
least.
Okay.
Like 30.
Okay.
So like 40 maybe?
So, just look at this so far, and you guys tell me, for an ogive graph, do you think you should be thinking about averages or medians? Something on there that should tell you one of them already. See the percentages? Is that what average is all about, or what median is all about? That's median. So the median number of copies consumed, you guys are saying, is somewhere around one a day. Is that the median, or like, I don't know, it sounds a little, I'm gonna say that's like 20 coffees per day, okay?
Per day.
So I'm gonna say that's 20, so now I've got a scale on my graph. 20 per month, sorry.
Okay, I was gonna say.
Come on, guys.
How many copies do you
Give me a break, I'm tired. Okay, so there we go. So how do you turn this into a box plot? Real simply, you can take those numbers and turn them into the edges for your box plot. Because the 50th percentile, wherever that lands, is the middle of the box, right? That's the median, that's quartile 2. Quartile 1 has 25% of the data below it. Quartile 3 has 75% of the data below it. And there you go. So you could take this and turn it into a box plot pretty simply. So a box plot, let's go from the same scale. 0 to, looks like I have about 60. There's 30. There's 10, 20, 40, 50. You guys got it? I know it's not a real nice picture I'm drawing here, but I think it'll get the point across. So we'll say that this is actually at 100% right there. Okay. So to translate that into a box plot, just use the use the quartiles. So we said that 50% of people drink 20 coffees a day. So that's going to be the median. So there's the middle of the box. Quartile 2. So I don't know what your book problem says. It probably says something about quartiles up yet though. Where's quartile 1 on here? Well, find it. Here's 25%, right? What's that look like? 15? Yeah. We'll come over here and say at about 15, that's quartile 1. There's that first part of your box. And the 75th percentile is going to be quartile 3. So where's that look like? There. 30, 31. My graphs are sideways. Yeah, I know. I'm sorry. There you go. There's quartile 1, 2, and 3 for your boxes. Whiskers go out to the max and min, right? Let's see. So we've got a minimum of 0 coffees. That's not a true Starbucks enthusiast, but whatever. It's like that. And we've got a maximum of how many? Depends on how bad my graph is. A little less than 50 looks like to me. There's my other whisker. Could you actually take this data and now decide if you had any outliers? Yes. If there's any outliers, where do you guys think they're more likely to be, by 0 or by 50? This is pretty symmetric. This is kind of a little bit off, right? But it's decently symmetric, I think. I don't know, kind of the same whisker size each way, right? We'd have to check the lower and upper fence. I don't think there's going to be any outliers, though. Those aren't that crazy far away, so.
What do you think?
We'd have to check, though. So make sure you know those lower and upper fences for tomorrow.
11.
What is it?
30 minus 11, 20.
Yeah, so
Times 1.5.
let's do it.
30.
Let's see if there's any outliers. The lower fence is going to be,
It'd
what,
have to be
quartile 1,
negatives.
which was like we said, what, 15 minus 1.5. What's the IQR? It's like 31 minus 15 is like 15-ish. The upper fence is going to be the upper quartile, which we said was like 31 minus plus 1.5 times the IQR, which is like 15. So it's going to be 15 minus, you said like 11? No, that's more, isn't it? 100% of 15 is 15, 50% of 15 is 7.5, that's 22.5. 31 plus 7 plus,
20.
yeah, thanks, it's keeping me alive. Jeez. Okay, so this is going to be negative something. So do we have any outliers there? No, I don't think you can have negative coffees. This one's close, isn't it? That one's close. We've almost got an outlier up here, and I bet there's actually outliers. If I had not just made this data up, you know there's got to be a person in Pueblo who gets like 3 Starbucks coffees a day and ends up with 60. They're going to die soon.